Good morning. Myself, Dr. Govind Sharma, Assistant Professor, School of Applied Science, Suresh Gyan Vihar, University, Jaipur. स्टूडेंट आज का जो हमारा टॉपिक है दिस इज़ वेरी इम्पोर्टेंट फॉर बी टेक बी एस सी एंड गेट नेट many exam. Okay, we are going to start differential equation and topic is first order linear differential equation. Okay, what is the objective of the lecture the student is know about. After the lecture, student will able to understand the meaning of differential equation. What is differential equation? To know about the order of differential equation and to understand the method to solve differential equation. Actually, is the objective of this lecture to understand about the differential equation. In this lecture, we discuss about different type of differential equation, order of differential equation, and method to solve the differential equation. So different method we will use to find the solution of differential equation. And after this lecture, we have a small quiz. Okay, and 5 to 7 questions I will discussing during the lecture. So we continue and just I go to start with the whiteboard. Actually, I will solve the question and then you understand the meaning of differential equation and any other thing. So first I want to ask some student what is the meaning of differential equation? Differential equation is just the relation between some dependent variable and their derivative. So that's good luck. We're going to start. Okay, student. Now, first we take okay student. Differential equation. Differential equation. What is the meaning of differential equation? Let let we take y is equal to fx. Here, y is dependent variable. X is independent variable because y depend on x. So there also exists their derivative dy upon dx. Okay. So if let ax plus x square. This is the equation. This is the relation between dependent variable and independent variable. So this is can be called equation. We can call equation. Now we use their derivative is also their derivative. Now I write dy upon dx plus py is equal to q. Here we find that this is the derivative. This is dependent variable and X is independent. So here is a function of x. Okay, it may be x, x square, x cube, e to power x, log x, sin x, any other. It is. So this call this relation is called differential equation. It's called differential equation. Now I come on the definition of differential equation. What is the meaning of differential equation? Differential equation is relation between, if anybody have knowledge about this, then easily find out differential equation is a relation between x. X means independent variable, y dependent variable, and their derivative. Dy. As seen, we can dx upon dy also use. This is also a differential equation. Okay. Now, our interest to solve the differential equation. Here I write some differential equation. Dy upon dx plus xy is equal to x cube. This is called y. And mm, d2y dx square plus x dy dx plus y is equal to equal. There are some difference. The both differential equations have a difference. If you see that here in equation first we use dy upon dx. Here the term we are using dy upon dx, and here we term use d2y. So what is the difference between that? That here we use higher order, higher order of differential equation. This is what is the meaning of order? To solve the equation, we need order of a differential equation. And order, what is the order of differential equation? Highest power or order. Don't use power, I think order is better. Highest order of derivative exists in differential equation is called order of differential equation. Okay, student? Highest order of derivative. In the sense, we see here in equation 2. Here, highest derivative exists, order is 2. So, in equation 2, the order of differential equation is 2. Similarly, in equation first, the order of clear think this is better approach to understand. Now we come to the degree. Degree, differential. What is the degree of differential equation? Degree can be defined the power or degree of highest highest derivative derivative in differential equation without radical sign. Radical or fraction. ठीक है? Now we can write the equation. Example, t square y df square, okay, dy dx square, cube, this is cube y cube is equal to. This is also a differential equation because here the relation between x, y and derivative. What is the degree of? What is degree of differential equation? What is the degree of? No, guess. Right. Here, highest derivative means d2y dx2 and its power is okay. Come to the definition, the power of highest derivative. Which is the highest derivative is d2y dx2 and its power is 2. So degree, and I can also ask to you what is the order? Order is also because highest derivative order is 2. Okay. So what is the degree of differential equation? 2 because higher derivative exists the order 2 and power is equal to. So again, for example, an example more we take d2y dx2 plus dy upon dx here here order of differential equation is 2. Why? Because higher derivative exists in this equation is here. Now degree of differential equation is 1 because highest derivative power degree is equal to 1. Okay. Now let's move. Here our interest to solve the differential equation. So here are some form of differential equation. First, exact form of differential equation. This form, the equation in this form, m dx plus n dy is equal to 0. This is this type of equation is called exact or exact form is del m upon del y is equal to del n upon del x. If del m upon del y equals to del n upon, okay, where m and n are function of x. Clear? Now, second, second linear differential. Here we talk about first order differential equation. I write here we are talking about first order and 1 degree of first degree differential. Okay, the equation, the differential equation of form dy upon dx plus py is equal to q. Here q is the function of x. This type of equation is called linear form of differential equation. First degree linear differential equation. This is called first order linear differential. Now the solution of differential equation, this type of, we have to find out we have to find out if. If means integrating factor is equal to e power pd. Okay? Here integrating factor is e to power pdf. Now we write the solution directly. Now, now we write the solution. Y dot if equal to integration qx if plus c is the constant. So the solution is y e to power pdf qx e to power pd. This is the solution. This is the solution of linear differential equation. So here third one, third type differential equation, homogeneous differential like differential equation like dy upon dx x square plus y square x square. Here we see the each term have same degree, same degree. x degree 1, y degree 1. The each term have same degree. That is called homogeneous equation. That if the each term have same degree, so the equation or differential equation is called homogeneous differential equation. Okay, how to solve it? So we replace here, we replace, or we can assume y is equal to vx. Okay, here v is also a variable. Then dy upon dx is equal to become v plus x dv upon. Now we put here. Now replace in even equation v plus x dv upon dx is equal to x square y replace with v square x square upon x dx. Okay, x square is common here. Sorry, vx. V 1 plus v square upon x square. Okay, so now this equation becomes v upon dx 1 plus v square upon, or we can take implied dv upon dx is equal to 1 plus v square dx. Can solve it and use variable separation method. Okay, now today our interest to solve the linear differential equation. Okay, so so our interest to solve linear differential equation. So I take an example of linear differential equation. Example of linear differential equation like dy upon dx is equal to plus 5y is equal to, or may I can e to power. Okay, here this is the linear form of first order differential equation. This is linear form of first order differential. So we have to calculate if. Okay, if calculate, then if, you know the formula of if. We know the formula is E integration P. Here, what is the value of P? Here, P is 5, 5 dx. Integration. So this will become e to power 5 constant dx integration. Okay. Now, the solution of equation y dot if is equal to if qx if plus what is the value of if y e to power 5x is equal to qx. What is the value of qx? E to power x. What is the value of ix? E to power 5 dx. Because integration sign, the here is also dx. Okay. This will become e to power 6x dx plus. Now by solving this, it becomes e to power 6x. Here bt y e to power 5x is equal to e to power 6x upon 6 plus, and y is equal to imply y is equal to, इसको राइट साइड में लाएंगे तो it becomes e की power x plus c e की power. This is the solution. This is your okay, student. I hope this is easy for you. Now I take another example. Example number 2. This is tougher than previous one. Let dx upon dy plus x 1 plus y square is equal to e minus tan inverse y upon 1 plus y. Sometimes or sometimes this is write as 1 upon y square plus x minus e minus tan inverse y dy on dx. दोनों the both equation are same. Okay, when we uh, solve it for x dx upon dy, this will become a perfect equation. Now we do the solution. Dx upon dy plus x 1 plus y. Here you see that y is independent variable and x is dependent variable. So, and this is first order linear differential equation. So we first find the if of equation. How we find out if? If is equal to, we know, PD. Okay, we know PD. Here P is equal to 1 upon 1 plus y, and Q is equal to A tan inverse y upon 1 plus y. This is very important example also. I can write here very important for exam pattern. Many exam you can find this type of example, this type of problem. 1 plus y square. Here, sorry, y. This becomes integration of 1 upon 1 tan inverse y. This is your answer. Now, the solution. Y dot if is equal to qy. Sorry, here we write the solution in form of x. For dependent variable is x. X if is equal to qy if plus log down x if. What is the value of if? E power tan inverse y is equal to qy is e की power minus tan inverse y upon 1 plus y square dot if e power tan inverse y. So the solution becomes e 1, sorry, here dy also 1 upon 1 plus y square dy plus c. So this becomes tan inverse y plus tan. This is the solution of first degree linear differential equation. Okay. Now I repeat the process. First. Let this is the equation dx upon dy plus y 1 plus y square upon. Here this is the linear form of differential equation. In the form dx upon dy plus px is equal to qy. This type of equation. This is can be write as px. This type of differential. Okay. So here p is 1 upon 1 plus 1. Okay. So if becomes if is equal to e integration p dy q e to power minus tan inverse y upon 1. We can write the solution. I think this is very helpful for you to understand the process to solve linear form of differential equation. Now, in next, we will talk about exact form, homogeneous equation, and how to reduce. And actually, uh, this is the form of differential equation dy upon dx plus py qx dot y. This is they call the reduced to reducible to linear form of differential equation. And this equation students also called Bernoulli equation. Bernoulli. And now, in next lecture, we will try to solve this type of equation. This equation will be convert. First, we convert equation in linear, and then solve. Okay. So today we have discussed about two examples of linear differential equation. This is very helpful. The second example is very important uh, for your exam. Okay. And now we come to the quiz. Okay. Now we discuss. Today we discuss about the differential equation, definition of differential equation, order of differential equation, how much type of differential equation are, and how to solve it, degree of differential equation, and how to solve the differential equation. They are mainly exact form we have discussed, and we have discussed about linear differential equation and homogeneous also. And I give you some brief knowledge about Bernoulli differential equation. So now the time of quiz, I come to the quiz. Students, now we come to the quiz. Now, the first question. A differential equation is a relation between y and x, relation between dy upon dx, y and x both and not. If you go through the PPT and the lecture today lecture, then you easily find out. I write the first line that the relation between differential equation is the relation between the dependent variable, independent variable, and their derivative. So the first one, the relation between dy upon dx, y, and x is the right option. Order of differential equation. What is the order of? Highest order of dependent variable, highest order of independent variable, highest order of derivative, and none. So very simple. This is also definition of order of differential equation. Order of differential equation. The highest order of the highest order of derivative is called the order of differential equation. Okay, it's called the order of differential equation. So it is also C is right option, I think. Okay, let dy upon dx plus 5 by is equal to x. This is I have already discussed in the lecture. Which type of differential equation? This is exact? No. Exact form is mdx plus n dy form. What is the exact form of differential equation? mdx plus n dy. And thus how we know this is exact? Then we check del n upon del x and del m upon del y, and the both are should be must be equal for exact. So this is not exact form. Second is linear form. Maybe in lecture I discussed that the form of dy upon dx plus py is equal to qx. This is the form. It's called linear form of first order differential equation. That means here p, what is the value of p? P is 5, qx is equal to x, and this is already I discussed in the lecture. Homogeneous form of differential equation where all term have the same degree is called homogeneous form of differential equation. And Bernoulli, we in the last of the lecture I discussed. about the Bernoulli equation that dy upon dx, this is also a part of linear differential equation because dy upon dx plus dy is equal to qxy to power n. It's called the Bernoulli form of the equation. So in the third question, the right answer is linear form of differential equation. Here, find the IF of the differential equation. Then here P is equal to this. If we compare this equation with the linear form of differential equation, this dy upon dx plus py is equal to x, qx. Then p is equal to x. Then if, we know the formula of if is equal to integrating factor of a differential for linear differential equation is e integration p dx. So it becomes here p is equal to x, then if is e to power integration x dx, and x, we know the integration of x square by 2, then the if is equal to e to power x square by 2. Okay students, now the last form, write the exact form of the differential equation. This is very simple. I already many times told you that this is the first type of differential equation, exact form differential equation. M dx plus n dy is equal to 0 is the form of differential equation. Okay, what is the mean of here? M and n is function of x and y. And how we check this is exact or not? This is exact or not, we check by del n upon del x. We find the value of del n upon del x and del m upon del y. Then we see, we check these are equal or not. If these are equal, that call the equation is exact form. This is also mentioned in lecture also. I I describe very well. Okay, thank you, thank you to listening me, and I think this is very helpful for you. Next, we will discuss about Bernoulli equation. So myself, Dr. Govind Sharma. Thank you very much. Okay, friends.